Let's see some example. Suppose average age for marriage is 25 for women and 27 for man. If standard deviation for women is 4 years, and what is the probability that a random selection of 32 women have an average age for marriage between 26 and 27? So since the value of n is 32, it is considered to be large. So here we can use central limit theorem to find out the probability. So you once tried this out. Let's see how to do this. So given a mean of the random variable is 25, and we already know that the sigma of x is standard deviation by root n. So n is 32. So we define this new we define the new mean and variance of Sn. Now we normalize the values of Z1 and Z2. Since they asked us to find the average age of marriage between 26 and 27. Now, first we need to draw a graph. We already know that the normal CLT can be approximated as a normal distribution, and the normal distribution will be in this shape. And since the mean is 25, since the mean is 25, the zero of the new normalized will lie there. And for 26, we need to find the normalized value of C. So Z1 equal to x1 minus mu x by sigma mu x. So 26 minus 25 by the new standard deviation, 4 by root 32. This new normalized constant is 1.41. Now we will calculate value of Z2, which is x2 bar minus mu x by sigma x. 27 minus 25 by 4 root 32 will get 2.83. These are the normalized values of the new random variable, and we were asked to find the probability that the average age is between 26 and 27. So we already saw in this graph that the area under the graph is the CDF. So we need to calculate the probability between 26 and 27. So we just need to subtract the areas. Either you can take from minus infinity to z or 0 to z. I would prefer to take 0 to z because anyway subtraction half of the part will go. So now it is 1.41. So you can mark 1.4 here and 0.01 here. So the value of that is 0.4207. So we have written that here 0.4207. This is the probability of the normalized random variable for the x equal to 26. Now we will find for 2.83. 2.8 is here and you have to go till here because 0.03 is in this column, and in this row you have to choose 2.8. So it is 0.4977. So we have written the same here, 0.4977 for the x equal to 27, and probability for x between 26 and 27 is uh, the subtraction of these both probabilities, that is 0.4977 minus 0.4207. So the probability for the probability for an average age for marriage between 26 and 27 is 0.077. So I would like to repeat the process. Uh, so first you need to calculate the mean and variance of Sn. Then we calculate the normalized value Z, and we use the approximation probability of Sn less than C equal to normal CDF, where the CDF value is 1 by root 2 pi minus infinity to Z e power minus x square by 2 dx. So these values you can the value of this phi of Z you can calculate from this graph, plotting the first digit after decimal in a row. Like if you take 2.8, then if you want the value of 2.84, you have to take 2.8 here, and you have to search in the column of 0.04. So like that you will get the value of CDF. So when we are given a question, we have to just plot the graph, mark the mean, then mark the mean 25. Then we have to calculate the new standard deviation, which is sigma by root n. Then we have to find the normalized constants for the 26 and 27. Then we have to find the probability of 1.41 and 2.83 from the tables. Then since in the question they asked, we need the probability that it lies between 26 and 27. So we just need to subtract the two values, then you'll get the probability. Is that clear? In similar way, you can try this question. So now we'll look at this question. Since the average salary for a graduate is 64,140 with a standard deviation of 18,405. Find the probability that the 31 randomly selected graduates have an average salary higher than 74,000. So since here n value is 31, it is approximately greater than it is greater than 30, and it is considered to be large. We follow the same procedure. So given mean is 64,000. So we plot that here, and we were asked to calculate. Sorry, we were asked to calculate for average salary higher than 74,000. So we need we need this shaded part. So greater than 74,000. So here mu is 64,000, and standard deviation is sigma by root n. You'll get the new standard deviation. Then we find the normalized constant using the formula z equal to mu minus sigma x by sigma x. Uh, sorry, z equal to x minus mu by sigma x. So 74,000 minus 64,140, which is the mean, and divided by sigma x, which is sigma by root 31. So this value is 2.98. So we need this shaded region. So from the whole one, we can subtract, we can subtract this PZ less than 2.98. So for finding this probability of Z equal to 2.98, we can go and refer to the tables. Since we are taking here from infinity to Z, you can take what is the value? 2.98. So 2.9 is here, and 8 is here. So the value of that is 0.9986. So we can subtract that value 1 minus 0.9986, which is equal to this. So this is the probability for having an average salary greater than 74,000. Or you can also do in this way by using the left table. Since this half of the graph is 0.5 minus 0.4986. You can see 2.98 in the left table also. 2.98 is this 0.4986. So that you can subtract from 0.5 also, you'll get the same value. So this is also a similar model. You can try it out for 5 minutes. So the average time to graduate from a university with a bachelor degree was 4.68 years. If the standard deviation is 1.5 years, find the probability that a random space of 40 graduates finished their graduation between 4 and 5 years. So here also n equal to 40. So we can consider or we can use central limit theorem. So the mean equal to 4.68 and the new standard deviation equal to 1.5 divided by root 40, which is equal to 0.23717. Now we find a normalized constant for 4 and 5. So the mean is 4.68. So the zero of this will coincide with 4.68. Now for 5, uh, we can use the formula z2 equal to x minus mu by sigma x. So 5 minus is 4.68 divided by sigma x, which is 1.35. And when we take 4, uh, 4 minus 4.68 by 0.23717, which is equal to minus 2.87. And we write 4, 5 here, and the respective normalized constants there. Even though we got negative sign here, when we take the probability, we take the absolute value of this and find out the value of probability from the table. But since it is opposite, we will have to add the probabilities for finding the probability of x between 4 and 5. So for 2.87 from from 0 to z, 2.87 will get 0.4979, 0.4979. And if you want 1.35, 1.35, you'll get 0.4115. So we have written these values here. And now we were asked to find between 4 and 5. So here we just have to add the areas from 0 to 1.35 and 0 to 2.87. But in the previous case, we have subtracted because uh, both the values were on the same side of the mean. But here, if in such situations, if we get on the either sides of the mean, then you should add the areas. So 0.4979 plus 0.4115. So the probability that 40 graduates finished between 4 and 5 years is 0.9094. So these are three different possible cases. And here we conclude central limit theorem also. If you have any doubts, you can ask. If you have any doubts, you can ask or else we'll end the session.